roadmap to clean energy using laser beam ignition of boron-hydrogen fusion. Introduction. When the field of nuclear physics was created by Lord Rutherford just after 1900, it was evident from the beginning that the energy exchange for nuclear processes are about 10 million times higher than those in chemical reactions. The binding energy of the protons and neutrons in a nuclear is of the order of 10 million electron volts, while the typical chemical reaction binding energies are of about 1 electron volt. Only using Rutherford's experiments with Albert Einstein's explanation of the connection between mass and energy, as demonstrated by the most famous equation in physics, E equals mc to the second power. C is speed of light, and E is the energy contained in mass m. It was evident that the burning in nuclear reactions is related to 10 million times more energy than in chemical reactions. There are two types of nuclear reactions that can yield energy: fission and fusion. During the fission process, a heavy element like uranium element number Z equals 92 splits into two elements and neutron emission, while during the fusion two light elements are to be combined into a heavier one. The nuclear fusion of the light elements from the one proton hydrogen Z equals 1 up to iron Z equals 26 can release energies of the order of few mega electron volt per reaction. The most important nuclear fusion, namely the one that gives life to our planet, is the hydrogen cycle, producing the helium nuclei and yield in the energy of the sun. This cycle includes the weak interaction of proton-proton fission, creating a deuterium that further collides with a proton to get the helium-3 isotope that fuse with another helium-3 to get the final alpha nucleus. The proton-proton fusion cross-section has by far the lowest cross-section of this chain of actions, and it is given by sigma p plus p equal d plus electron plus v equal s per e explanation minus 2 pi n, where E is the positron and V denotes the neutrino. of the electron class S per E equal 4.0 times 10 to the minus 46 kilo electron volt centimeter square per E, and N equal N pi E to the second power per HV, where V is the relative velocity between the two colliding protons. The rate and timetable of this cycle are dominated by the H-H interaction of the nuclei of the light hydrogen H, the protons. The fusion power is in general given for the interaction of particle 1 with particle 2 by P equal N1, N2, sigma V, VE joule. The energy power in watt P is proportional to the number densities N1 and N2 times the rate sigma V, where sigma is the cross-section for fusion and V is the relative velocity between the two fusing particles times the volume V where the fusion reaction takes place times the average energy released by the fusion reaction E. For our sun, the hydrogen rate of fusion is of the order of sigma V equal 10 to the minus 43 power centimeter cube per second, an extremely small value. The fusion is possible because the sun is extremely big. In order to achieve fusion on our planet in a controllable way, one has to reduce the volume by many orders of magnitude, and this is possible because we look for strong interaction fusion with a rate sigma V of about 10 to the minus 14th power centimeter cube per second, namely many orders of magnitude larger. For this purpose, in the context of energy production on our planet, the fusion of the heavily hydrogen isotope deuterium and tritium and the hydrogen H reaction with the boron isotope 11 B11 are of great interest. D plus T equal helium plus neutron plus 70.6 mega electron volt. H plus B equals 3 helium plus 8.7 mega electron volt. Using equation for industrial power plant of P equal 1 gigawatt with an energy output per reaction of about 10 mega electron volt with the maximum reaction rate of sigma V equal 10 to the minus 15th power centimeter cube per second. We need N1, N2, V equal about 10 to the 36th power centimeter minus centimeter to the minus 3rd power. There are two distinct possibilities to achieve this. Emit a continuous operation with magnetic confinement of dilute plasma with a density order of n equal 10 to the 13th centimeter to the minus 3 minus to the minus 3rd power. Large volumes V equal 10 to the 10 power centimeter cube with the confinement of the reaction plasmas by magnetic fields and alternativity inertial confinement of compressed solid-state plasma with densities number of 1023 10 to the 23rd power centimeter to the minus 3rd power and larger for pulsating operation. The discovery to the laser paved the way from the beginning to use it for miniaturization of the ignition for a controlled pulsating fusion energy generation in a controlled way in power reaction. The following development at an National Ignition Facility (NIF) in Livermore, California, with the largest laser in the world, arrived at fusion energy gains rather close to, but not yet, the desired ignition point.